Okay, so in this video, we'll be covering question fourth, which is explain any four common feature engineering techniques for continuous or categorical data. Now let's see. We have feature engineering, where our first step for feature engineering is scaling or normalization. In this, we scale or normalize features according to either Z-score or min-max scaling, which are helpful for machine learning model which increases the predictability of machine learning model and dampen the effect of outliers. Often, it is quite helpful in models which are based on distances or gradient. For example, k-nearest neighbor, support vector machine, and gradient descent. Then we have binning, which means converting continuous data to discrete or categorical data. Here we divide a numeric feature into intervals. For example, let's say we divide age into multiple bins. For one bin is for 0 to 18, which is considered as child. Then we divide one bin as 19 to 35, which is for young adult. Then we for 36 to 60, which is for adult, and for 60 plus for seniors. Now here we try to reduce the sensitivity to noise and it may capture the non-linear relationships, right? Then we have one-hot encoding, also called as uh, get dummies. In pandas, we can use pd.get dummies to get one-hot encode of any feature. Here we convert each category into a binary indicator feature. For example, if we have a color feature and we have values red, green, and blue, then for each of those values, we will have those many columns. And if the value is red, then on the column of red, we have one rest zeros. This converts our categorical features so that they can be fed into the ML model. Then we have interaction features or polynomial features where it is used to cover non-linear relationship between the data. For example, area is equal to height into width, BMI is equal to weight upon height square. This captures the interaction that the linear model or linear regression misses. For example, there might not be linear relationship between feature and target vector. So we use polynomial features or interactive features to add those relationship and make our predictability of model better, right? For example, either we log power transform to reduce skewness, dimensionality reduction using PCA, embeddings for text, etc. Now let's see B part of the question. Uh, what is sampling from a distribution? Describe inverse transform sampling and Monte Carlo sampling. Let's see. Yeah, we will discuss about two sampling methods, that is inverse transform sampling and Monte Carlo sampling, often which is applied using Monte Carlo method. First, in inverse transform sampling, we generate all the data with bootstrapping, that is random sampling with replacement. Here we use the cumulative density function for that sample, and our goal is to first sample from a distribution with CDF. In inverse transform sampling, we use CDF and we generally take a random value from 0 to 1 and use them to generate CDF and to do sampling. For example, we can uh, find exponential distribution with rate lambda equal to 1, etc. Then we can let's describe Monte Carlo sampling, in which we use Monte Carlo methods. That is, we define a particular domain of possible inputs, and based on those inputs, we do the sampling. Here, Monte Carlo sampling is often used for approximating integrals or expectations, right? Th- This is the real world example where we use Monte Carlo sampling for approximating the integrals. And here also we define possible inputs like based on that, right? This covers our fourth question B part. I hope you find this helpful. Thank you.